Hi everyone, today we're going to start looking at right angles in geometry, and that includes odd shapes and circles. So let's get started. There are lots of geometric figures which involve right angles, and it's important to recognise these so that we can actually apply Pythagorean theorem to them. So I'm hoping you know these shapes, but we'll go through them anyway. First of all, we've got a rectangle, which is a quadrilateral in which all four angles are right angles. And if we have a look, there's a right angle there, there, and there. We also have a rhombus, which is a quadrilateral, which has sides equal in length, and its diagonals bisect each other at the right angles. So the right angles are on the inside instead of the outside. And a square is tricky in that it's both a rectangle and a rhombus, and it contains basically both lots of right angles. So you've got right angles on the outside and on the inside too. We also have the isosceles triangle, and here's something you may not have seen before. We used to always use height when we're talking about this upright of a triangle. Well, we now use the term altitude, and we also have an equilateral triangle here. Now, quite often you've got to find the right angle of a triangle, and you're given an odd shape. So there's a bit of a process that you use for working out how to do it. So let's go through this very, very quickly. So to solve problems involving geometric figures with right angles, first of all you draw a neat diagram, and you've seen some of mine, and I know mine aren't that neat, showing the information given. You use a symbol such as X to represent the unknown length. You identify a right angled triangle to which you can apply Pythagoras' theorem, solve the equation using the theorem, and if appropriate, write the answer in sentence form. And I'll demonstrate in a moment what that actually means. So let's have a look at this first example. So the longer side of a rectangle is 12 centimetres and its diagonal is 13 centimetres. Find first of all the length of the shorter side, and secondly the area of the rectangle. So if we have a look, if you draw your picture and then draw in the diagonal, you can see you've got a beautiful right angled triangle here, and it'll be easy using Pythag to actually find the length of that side. And I'm not going to go through all of this, but here it is here, and we can determine that the shorter side is actually 5 centimetres, and putting that into the area formula, you can see you've got 12 centimetres by 5, and that's going to give you 60 centimetres squared. It's pretty straightforward. In a moment you can go on and have a go at doing these questions, keeping in mind when it says to find the length of the diagonal for these rectangles, that's the diagonal there. So I'd actually be drawing that and drawing that diagonal in just to help you. I'm going to just go through the examples now, and you can go back through the PowerPoint presentation and have a look at these questions later. Now a rhombus has diagonals of length 8 centimetres and 10 centimetres, and find the length of its sides. So what it's saying, it's got these diagonals. There's one down here, this is 8 centimetres in total. This one down here is 10 centimetres in total, and we've got to find the length of the sides. And if you bisect it up, you'll see that you've got your right angle here, and it's going to be very easy to work out the answer to that side. And once again, here we go, there's the process there, and you're going to end up with the sides equaling the square root of 41 centimetres long. And there's a couple of questions for you to continue on and practice that as well. Now we're going to start looking at some circles. There is this wonderful investigation in the textbook, and if you've got a set square you can certainly give it a go, but I'm going to help you out a little bit, and I actually have it here digitally, and we can go through it here, and it might make things a little bit more interesting and make sense. So the first thing investigation asks you is to actually mark 2 points, label them A and B, and make sure they're 10 centimetres apart on a piece of paper. You then join them together with a lovely straight line. Now you grab yourself a set square. Now that's one of those kind of odd shaped rulery things. Quite often it's hollow on the inside, where it's got a beautiful corner and then a bit of a long length. Okay, and it asks you to actually lay the set square down so that points A and B actually go on the edges of the set square, and they fit nice and neatly. And at the point of the set square, you've got this little point here up there called C. Now what you do is you mark that point. So I'm just going to click on that to mark the point. Okay. The next, oh no, I'm going to go back a bit. Sorry, I missed a step. Typical. Now what we need to do is once you've marked that point, you're then going to slide your ruler so that the point moves, but not where the A and B is, and we'll mark that point as well. So I'm just going to go around, and you'll see what I mean in a moment. I'll go around here and just quickly mark them. Like that. And I'll go back around the other side. And you might be able to see a shape forming. Okay, can you kind of work out what that shape is? Let's have a look. The shape we've actually formed is a semicircle. So using a right angle, we've actually been able to form a semicircle, which I think is pretty nifty. Now, what's that got to do with anything? Let's find out. So you've done this investigation, and you've found that the angle in a semicircle is actually a right angle. A couple of little terms and things I want you to keep in mind while we talk about this stuff. And you may remember the diameter goes right across the circle. The radius goes from the center out. A chord kind of cuts across a circle and it joins at 2 points, or you mark 2 points of a circle, draw the line across, and it's called a chord. Now, chord actually comes from the Latin word chorda, which means bowstring. So if you think of like a bow, as in bow and arrow, that looks like the bowstring, doesn't it? And the other thing that's the other line that's sitting on the outside of the circle is the tangent. I'm just going to go to the larger screen. Makes things a bit easier to see. So the chord of a circle, if we take the line drawn from the center of a circle as far as the chord, it actually bisects it in half, but it also gives us a right angle down the bottom near the chord. And the tangent, if you think of the tangent doesn't actually cut into the circle, but it goes across the circle, and where the point of contact is, there's actually a right angle formed. So if you've got your tangent going across, you've got your radius going from center out, where they meet, it actually forms a right angle. Okay, now here's an example of how this could work. So a circle of a radius 8 centimeters has a chord of length 10 centimeters. Find the shortest distance from the center of the circle to the chord. Let's see if we can just deconstruct this a little bit and see what we've come up with. So we've got this circle here, and we've got the center here, which is O. We've got 1 point here, A, and 1 point, C, and a chord has been drawn between A and C. And that chord is 10 centimeters long. The distance from the center of the circle out to A is 8 centimeters. And then we're trying to find the shortest distance from the center to the chord, which is along here. Now that line cuts the chord clean in half. So if you've got a 10 centimeter chord, half of that would be 5 centimeters. So what I've done is I've actually taken that triangle, I've drawn it over here to try and simplify and make it a little bit easier to see. And once you've got that, you can see you've got a right angle here, and this side must be the hypotenuse. So using Pythag, we can actually find the value for x. So using the formula a squared plus b squared equals c squared, we put in what we know. So we don't know what the value of x is, but we do know the value of b, which is 5. So we've got 5 squared, and we also got the value of c, which is 8. So we've got 8 squared. If we expand those out, we're going to get x squared, I should say simplified, shouldn't I? x squared plus 25 equals 64. If we rearrange that equation, we're going to get that x squared equals 64 take 25. So therefore x squared equals 39. X will equal square root of 39. And in this case, we go for finding the square root of 39, which is 6.24 centimetres. And that's how you do that question. I really do suggest that you kind of pull out the information that you know and draw just what you need to know, because that looks very confusing when compared to that. That looks a lot simpler. Now I've got a couple of questions I want to go through with you, and then you can head off on your merry way. Let's have a look at this. Consider the circle alongside with the diameter PQ. So there's our diameter PQ. What is the measure of PRQ? Let's have a look. PRQ. It's asking what is this angle in here? Now it's a right angle, so it's obviously 90 degrees. And then the next part says write down an equation relating to A, B and C. Well, if we've got a right angle triangle, we must know that that is the hypotenuse. And because the equation we know is Pythagoras' theorem, where a squared plus b squared equals c squared. But all the questions aren't like that. If you look at the next lot, you need to find x, once again using Pythag, and giving reasons for your answers. Now this is I couldn't quite work out what giving reasons for your answers mean, but it's basically asking how you know that this is a right angle triangle. So for example, this is within a half circle, semicircle, so you know it's a right angle triangle. And this is based on a chord, so you know it's a right angle triangle. This one here is based on a tangent. So that's actually what that question is asking. Then there's a few more questions, and if you get through all of those, there's a puzzle question at the end. I would really love it if you could get through all this work in the first lesson this week, because I've actually got a little bit more work for you to do before we start back next term, where we're going to look at some problem solving using Pythagoras for a week, and then we've got to look at some trigonometric ratios. Okay, any problems, please direct message me and I'll get back to you as soon as I can. See ya.